Hi everyone, so this topic is expanding and factorization. So this first video will be on expanding and then I'll have another video there for factorization. Expansion and factorization rules, so there's a few rules here that make it really simple, a lot easier to work things out. The first one, we've got the distributive law. So when we expand this with our brackets, we take the a that's outside and we have to multiply the a by the b and then the a by the c. So we'll get a times b plus a times c. That's simple. The product rule, this time we have to multiply everything in the first brackets by everything in the second bracket. So we'll have a times c, and then we're going to have a times d, and then we've got to do it the same with the b. So we'll have b times c, and then b times d. This product rule often has lots of different names that people use it. Some people call it the crab clause because you see the little pink lines there I've drawn kind of look like a crab claw. Some people use FOIL, first, outside, inside, last. It's up to you, it's whatever method you find works. Difference of two squares. This rule, you can obviously use what we did with the product, but if you notice it's a difference of two squares, and what you notice here is that it has a plus b multiplied by a minus b. So you've got the a's and the b's are the same. And if you can see that, one bracket's a plus and one's a minus, it's a really quick expansion. And it's just a squared minus b squared. If you did the product rule with this one, the one before, and you expanded it, what you'd find is the middle two terms would end up cancelling out. Perfect squares, once again, you could do it by using the product, do a plus b multiplied by a plus b, expand. But once again, there's a quick rule that if you just learn it, it can make things a lot quicker. So if you have a plus in the middle, it's a squared plus 2ab plus b squared. If there's a minus, then it's a squared minus 2ab. This second part here, though, is still plus b squared because obviously if you have minus b times minus b, two negatives become a positive. Just got a few examples here. I think there's 6 to have a go at and just to see different situations you might come across and how to solve them. Example 1, expand a. We have 5 times 4 plus x. So that's just that first distributive law. So for the first couple of questions, for maybe A and B, I'm going to use lots of different colours just so you can see the process of where my numbers are coming from. And I'm going to do probably an extra line of working out that you won't do once you become really comfortable with this. So this first one we're going to expand. We're going to remember we've got to do the 5 times 4. We'll have plus, and then we have to do the 5 times x. And then we can just put those together and we'll get 20 plus. And 5 times x, remember, is just 5x. B, we've got x plus 2 multiplied by x plus 5. So first of all, I'm going to go x times x. Then we're going to have x times 5. 2 times x. And then we'll have 2 times 5. Then we can simplify that down and we'll have x times x, which is x squared, plus x times 5, 5x, plus 2 times x, 2x, plus 2 times 5, which is 10. And then from here we can simplify our like terms. So we'll get x squared, 5x plus 2x, which is 7x, plus 10. Now remember, x squared and x are not like terms. They are not the same. One's x squared, one's a single x, so they are different, so we can't combine those two. Now from part C onwards, I'm not going to do the nice crab clause expansion. I'm just going to write the answers. C, y plus 1 multiplied by y minus 1. If you look up at our rules, you'll see that's a difference of 2 squares. So we can easily just straight away write the answer. So it'll be y squared minus 1 squared, which obviously is just y squared minus 1. D, this is just a bit longer. Now we've got x plus 3 multiplied by x minus 3 minus x plus 6 multiplied by x minus 6. Two difference of 2 squares there. So we're going to do them separately and then we can combine if we can. And when I'm going to do this, I'm going to put both parts in brackets and I'll explain why in a second. So the first difference of 2 squares will give us x squared minus 3 squared. minus, and then the second difference of 2 squared, so it'll be x squared minus 6 squared. Now the reason I've put this in brackets is here, because we have this minus in the middle, it's minus everything after that, and because they're multiplied together, we have to minus the whole thing. So the reason I've put that in brackets is so we don't mess up with our negatives. Now I'm going to go and expand or simplify. So I'll have x squared minus 9. Now here we've got minus x squared minus x squared. That minus also has to be applied to the second term. So it'll be minus 6 squared, which will give us plus 36. Now if we look here, we've got x squared and we've got a minus x squared, the like term, so they will cancel. And then we have a minus 9 plus 36, which gives us 27. X plus 5 all squared. So that now it's a perfect square rule. So we can just go straight away and use the rule. So the rule is up here. I'm just going to put a star next to it right now. And we use that. So A is our x and the B is the 5. So we're going to have x squared plus 2 times x times 5 plus 5 squared. Then we just simplify. So x squared plus 10x plus 25. Done. Now this last one, f, it looks a bit difficult, but it's the same type of idea as what we've been doing. So everything in the first bracket has to be multiplied by everything in the second, just as we've done before. So we'll do x times x squared, then we'll have x times x, and then we'll have x times 4. Then we do the 2 with everything, so we'll have 2 times x squared, 2 times x, and 2 times 4. I'm going to simplify that down. So we'll have x cubed plus x squared plus 4x plus 2x squared plus 2x plus 8. And then we can just combine all our like terms together. X cubed, only got one of those. Then we have an x squared plus 2x squared. That will give us 3x squareds. 4x plus 2x, 6x, and then we have our 8. That is our basic expansion.